Hello students, we are back for Geology lesson number 7. We are back for Geology lesson number 7. And today we are going to talk about geysers. So a geyser is really kind of like a fountain or an eruption of water, superheated water and steam from the surface of the earth. And if you've ever been to Yellowstone National Park, they have a famous geyser called Old Faithful, and it causes that explosion of water about every hour. So what I want to talk about is, first of all, what is a geyser? So a geyser, not the same as a volcano. Since there are about 200 of them on Iceland, the island of Iceland, it comes from Icelandic word meaning spring, to spring. So to spring, geysers spring. And Iceland has about 200 of them. So remember, Iceland is the part of the mid-Atlantic ridge that is actually above sea level. So the mid-Atlantic ridge, remember, is the longest mountain range on Earth, even though most of it's underwater, but there's a part that's above water, and that is the country of Iceland. The 3 things needed to form a geyser. 3 requirements. Number 1, you have to have some heat source somewhere. It's geothermal energy, so that's the heat from the earth. In this case, talk about geology. Second thing, you need to have a source of water. Because a geyser is water, like boiling water. And third thing, you need to have some kind of plumbing system. Plumbing, some kind of maze or labyrinth or channels underneath the earth where this water can travel. So here we're going to have I'm going to just draw a cross section. So in other words, we're like cutting the earth in half, looking side view, a lateral view of it. All right. So here we can have mountain ranges up here. All right. Okay. So mountains. All right. So here we're going to start with the side view. This is all going to be the crust. Now this can extend down to the mantle. Usually not, though. It gets heated from the mantle. Okay. So on the surface of the earth, there are small cracks that water can get trapped in. So if we have rain coming down, it's raining, or there's water. All right, so the first step is raining. That water can go down these channels. All right, and there's some larger channels. There are cracks here. Let's see, it's all cracks. There are some like kind of hollow spaces, I guess you could say, cavities underneath where water can store. All right, so stored water can rest here. Down here, it gets hotter. So as you go down deeper into this earth, it gets hotter, right? We know about that. So down here, we could say this could be mantle area. So these can extend, and this is just all crust. But this is very hot. So this is your heat source right here. It's hot. All right? So that is going to heat the water up. Now, first step, it rains. Rainwater. So number 1, rain, which causes the water to go through all these cracks. And eventually, it starts to fill up these cavities. But obviously, due to gravity, it's going to fill up the bottom one. And then this one and the next, and then eventually like fill them all up, depending on how much water you have. All right, so step one is rain. Or rainwater getting into the cracks and the cavities. The next thing, this water now is heated up. And it's not just heated as you go down. Water's heated, but it's also pressurized. And under a lot of pressure. Because there's a lot of pressure at this bottom one, because all of this other water coming in. So this water coming in is creating more and more pressure in the bottom cavity. And under pressure. Now, this water actually is superheated down here. It becomes so hot and it's under so much pressure that actually raises the boiling point of water. Now, water normally boils at 100 degrees Celsius, right, or 212 degrees Fahrenheit. So 100 degrees Celsius, water will boil. However, this can get hotter than that. If it gets hotter than that, like on your normally at 110 degrees Celsius, it's going to convert to steam. So at 100 degrees Celsius, that's when water boils. That's when you convert from liquid to gas. Vaporization happens, right? But that's under normal pressure. All right, here there's a lot of pressure down here, high pressure. So it creates what's called superheated water. So the water's heated so much. Number 3, I'm going to put, actually, because it happens here, I'm going to just, I don't know if you guys can read this, I might have to zoom in. So it creates superheated. So superheated, super means above or more than. So superheated water. So that means the boiling point's the temperature which it boils. And normally water boils at 100 degrees Celsius or 212 degrees Fahrenheit. If it is superheated though, because it's under a lot of pressure, it will not vaporize. It becomes hot. So the boiling point, VP, increases. So when it's under a lot of pressure, the boiling point goes up. In other words, it's going to take more and more heat to get it to actually boil or to become steam. So it stays water. It could be like, it could be 110 degrees Celsius, where it should be steaming, it should be vaporizing, but it's still in liquid form. All right, so this is called superheated water. If something it increases the boiling point, it doesn't actually become vaporized, it stays in the liquid form because it's under so much pressure. So there's a lot of pressure building up now. All right, pretty soon this pressure cannot be tolerated anymore. All right, so pretty soon, after a point where the pressure builds up, we have to release the pressure. All right, so number 4 then is this pressure is going to be released. And that's usually when you get enough water. There's enough water creating very high pressure. Pretty soon the pressure is released and this water will go up and form a geyser. So the pressure is released and the water, the liquid water, goes through the surface of the earth, goes out. Earth's crust in the form of a geyser. So as the pressure is now released, because this water now is escaping, as the pressure goes down, then the boiling point will go down. So then it'll be back to its normal boiling point. And then that means it can boil or become steam. So that's why in a geyser, it's water mixed with a lot of steam. There's a lot of vapor in a geyser. Because now the water can actually boil. It can go from a liquid to a gas. So those are the steps. That's a geyser. A little different than a volcano, but it's a geological process. All right, so underneath, there's a lot happening. Underneath the surface of the earth. If you look down below your feet, you think there's nothing going on down there? Well, you're wrong. Wrong. You're severely mistaken. There is a lot happening. And hopefully you appreciate it a little more. Because I sure do. I love nature. I love science. I wish I could. Hopefully, I can give you some passion into studying more science or just learning more about nature. Because to me, there's nothing in the world. That's the most fascinating thing in the world is studying nature and how science works. And it's just anyway. Find your inner science nerd. And don't forget to show off your dance moves for the contest.